Okay, so how you doing? In this video, what I'm going to do here is I'm going to talk about y squared equals cosine x versus y equals cosine x. And the whole reason I'm going to talk about this is someone asked me about how could I explain it? What is the behaviors that goes on with y squared of cosine equals cosine x compared to this y equals cosine x? One of the things that I do want to point out here is that because this is essentially using a quadratic value, which is essentially making a square, it's not going to hold the same properties that, say, this linear function would hold for this part, well, not linear, that this periodic function would hold. And the reason for it is because what I'm going to have to do to actually graph this and what's going to occur. But it is important to understand the behaviors that do occur in the actual function. So what we need to take a look at here currently is let's observe just the basic of all basic cosine functions, where if I have y equals cosine of x and I don't have any amplitude change, I don't have any period changes, I don't have any phase shift or anything like that. So let's just start there and go very basic and understand how is it that this kind of alters everything. So when I take a look at this function y equals cosine of x, okay, my input values are my x-axis essentially here. So these are essentially angles of rotation that are formed by, in this case, because we're talking about radians, so we're talking about an angle rotation that's formed by a point traveling on a circle. And what is its output values going to be as it travels along that circle? So for instance, if we start here, we all know that cosine of 0 is 1, so at this point my coordinate is 1. Okay, so as we travel along the circle, what is the output going to be as I take the trigonometric function? So if I follow along 0, the other ones you know are cosine of pi over 3, cosine of pi over 4, cosine of pi over 6. You have 30, 45, and 60 degrees. And as we follow along, what you need to know about cosine is it approaches its first quadrantal boundary. So I have quadrant 1 between 0 and pi over 2. That it begins to decrease and approach 0. So as it goes to 0, it then at that point begins to record negative outputs, and the lowest negative output that it's ever going to have is negative 1 and 1. So what happens here is we notice that our range is limited to being negative 1 to 1. So these values are now limited to the y's between negative 1 and 1. So how does this change? Well, this is a periodic function, so if we look at one period, it simply goes from 0 down to, from 1 to 0, then it goes to its minimum, back to its 0, and then back to its maximum value of 2 pi. And those are all things that I believe most people know at this point. But then it just starts. So if we take a look at this period here, and I would just kind of draw this line up, all right? What we notice is that that's when it becomes cyclical, and here, so essentially we only need to really look at one period, because if we determine what's going on in one period, then we just repeat that over and over and over again because it's a periodic function. So there's that little recap of y equals cosine of x. So how is this different? Well, the only thing that we really need to occur here is that, okay, if I'm going to graph this, then I need to make it equivalent to y. So if I go ahead and I solve this just for y, I end up getting that this y, if I take the square root of both sides, I get y is equivalent to plus or minus. The number one thing that I think most people forget is that when you take the square root, that you must always take the plus or minus of that function. So when I take the plus or minus of that function, I get cosine of x. So what then begins to occur? Well, now I just begin to evaluate it, and then I can just begin to look at the patterns of what's occurring and what's the behavior. So, first thing that I want to take note of is that I can never take the square root of a negative. So just before I even do anything, there's some things that I can begin to look at this function and go, these values are not going to be defined in my function. So if I begin to now turn this graph, that was y equals cosine x, into this y squared of cosine x, I look at this graph and I go, where can values not make sense? And clearly what we can start to see here is that the values that are between pi over 2 and 3 pi over 2, I cannot input into this function, because if I take the cosine of any value between negative pi over 2 and 3 pi over 2, I'm going to have a negative number. And I can't take a negative value and take the square root of that. So therefore, these values on my graph are all going to be undefined. So therefore, I'm going to be skipping over these values. So continuing on with that, if I look over to this side, the values between negative pi over 2 and 3 pi over 2 aren't going to work either. So I'm not even going to bother plugging them into my function. So that right there just eliminated some work for me. The next thing that I'm going to do is I'm going to go, okay, let's look at the values that I can plug in. And what do I get? Well, the values that I can plug in are going to be anything that gives me a value that's positive. And whenever I take cosine, okay, for this, I'm always going to be limited to some value between 1 and -1 unless I change the amplitude. And the amplitude, remember, is always the multiplier of cosine. And even if I put the square root in here, well, I just take the square root of that value, and then that will also give me what my new amplitude is. For instance, I'm going to use something that's nice, but if I put a 4 cosine x in here, my new amplitude would shift this up to 2. Okay, so do you understand that? Now, it gets a little dicey and tricky if you start putting pluses and minuses inside of the square root. But just for all sake of purposes, that if I were to put a value in here, I would take the square root of it, and whatever that value is my new amplitude of my function. But let's talk about what this function actually looks like. So let's pretend that I just have the square root of the cosine of x, and I'm just going to use basic ones that I know. And the basic ones that I know are going to be the pi over 3, pi over 6, and pi over 4, 0, and 1. So let's talk about this, and I'm just going to talk about it as opposed to actually writing it. Well, you know, I'll write it down here. I'll record my work down here. So let's say I have this y equals, and I'm going to start evaluating the positive square root. So let's say I have the positive square root of the cosine of my function of x. Well, let's take the cosine of 0. Let's see if that changes anything. Well, the cosine of 0 is 1, the square root of 1 is 1. So I still have this point, and I'm going to start to plot my points in green. So I have this point 1. Okay? My next value that I'm going to evaluate is going to be pi over 6, which is 30 degrees. The square, and if I take a look at 30 degrees, when I plug that into my function, the cosine of 30 degrees is root 3 over 2. So root 3 over 2, if I take the square root of that, okay, the original number is like 0.8666. The new square root is like 0.98. So I'm going to have a number very close, okay, to 1. The next value that I'm going to evaluate is the 45 degrees, which is root 2 over 2. And root 2 over 2 is 0.707. If I take the square root of that, I get a number like 0.81. So I'm at this pi over 4, which is half of here, which is still a little bit higher. And then I now take a look at, well, let's take a look at 60 degrees. So pi over 3. So pi over 3, if I take the square root of that, is 1/2. So the cosine of 1/2 is, the cosine of pi over 3 is 1/2. So recording this information down here, if I take the square root of the cosine of pi over 3, I'm really taking the square root of 1/2. So take the square root of 1/2, and what you get there is that root 2 over 2. So if I go up to this function where it originally was, now I go to pi over 3 and plot that point. So let's then go to 0. Let's see what happens as this function approaches pi over 2. So as my function approaches pi over 2, let's plug pi over 2 and see what occurs. Well, cosine of pi over 2 is 0. The square root of 0 is still 0, so I get back down to this value here. So as this function, okay, it kind of stays a little bit more above my value when I go down here, okay? The thing we now need to know is that cosine, it's always going to hold the same properties of it's going to be reflexive across the y-axis here, so which means that these values are going to be reflective over here. So I draw that. So that's for the positive, and now the important part here is that most people forget this negative. So the negative is actually going to continue this pattern, except for all these values I now have, I take the negative of it. So I come down here and I start plotting their opposites. So I get that, and then I get this value, this value, this value, and then I'm back to 0. And I do the same thing over here, but essentially what's going to occur is that y squared of cosine of x is going to create this oval-like shape. And now I'm done essentially, because remember that it's periodic. So I've created this one oval, and now that I've created this one oval, since it's periodic, I just need to determine where is it going to become periodic again at. So when I take this, I've got this oval shape. Remember that my values between here do not occur. So I go back to where do my values occur again. And what you find here is that 3 pi over 2 is where they begin to occur again. So I draw this up here, go over here, and remember I take the opposite of it, so because of the y squared. So I keep doing this, I get that, okay? And what you have here is that I've got a periodic function, okay, that essentially is drawing a bunch of ovals. And that's what the y-squared's behavior is. And remember, the most important part here about all of this is this value, when I take the square root, that I take the positive and the negative, and what that allows you to find is, allows you to do that y-squared function, where what I have now is this periodic oval graph. So the basis of what we were really talking about is recognizing this function, where can values exist versus where they cannot. And because it's the square root, values cannot exist where I get a negative output. So I had to look at only where my positive outputs were and take the positive and the opposite of them. And then I plotted my points and I've created my graph. So I hope that helps with anything in the future. And if you do cubics, remember it's just the same exact thing if you take the cube root. So if you have any other questions, I hope I explained everything you were looking for. But if not, just leave me a little note and I'll try to explain some more out of that for you. Alright, so I hope that helps.